the 18th of September 1846, French mathematician Urbain Le Verrier sent a letter to the Berlin Observatory. The letter contained a precise mathematical prediction of a previously undiscovered eighth planet in the solar system. A few days later, within 1 degree of its predicted location, Neptune was discovered. Le Verrier was able to predict its location and existence based on the seemingly inconsistent orbit of Uranus. But something still didn't quite add up. Uranus' orbit still showed slight deviations from what was to be expected. This led some to speculate that there could be yet another planet beyond the orbit of Neptune. This potential ninth planet received the nickname Planet X. And in 1930, it was announced that it had been found. But Pluto was not what we expected to find. It was so tiny, both in terms of mass and size. So tiny in fact that it could not account for the orbital irregularities of Uranus. It wasn't Planet X. In 1989, the space probe Voyager 2 made a flyby of Neptune. New calculations based on the information it collected revealed that the orbits of Uranus and Neptune were just fine. It turns out that the perceived anomalies in Uranus' orbit was the result of not having sufficiently accurate measurements. There was no need for a Planet X, as everything checked out. In hindsight, the discovery of Pluto was completely accidental. While a certain fascination for the elusive Planet X continues to persist, most astronomers agree that its existence is unlikely. That is until just a few months ago, when new evidence came to light, which yet again opens up the possibility of a ninth planet in the solar system. And this time, the evidence is actually quite compelling. By studying multiple trans-Neptunian objects with extreme and atypical orbits, two scientists have found a strange pattern. This pattern, or orbital clustering as they call it, has about a 1 in 15,000 chance of being a coincidence. It's much more likely that a so far undiscovered planet roughly the size of Neptune has gravitationally influenced these distant bodies, leaving this orbital clustering in its wake. This potential Planet X would have such an extreme orbit that it would take roughly 15,000 years for the planet to orbit the Sun only once. To put that into context, 1 year on this planet would see the release of a staggering 2 fresh installments in the Half-Life franchise. Researchers estimate that if they are correct, they could visually confirm its existence within the next half-decade. You see this tiny red dot? That's a planet, an exoplanet orbiting a star 97 light-years away. And this is a star 129 light-years away with an entire family of at least 4 exoplanets. These photos and others just like them are the best images of exoplanets captured to date. The best image of a star, other than the Sun of course, is this photo of the star Altair, which is roughly 17 light-years away. It rotates at such a high velocity that instead of being spherical, it's gained a flattened oval shape. Before the International Space Station, there was another space station between 1973 and 1979 called Skylab. Unlike the modular construction of the ISS, Skylab was constructed and launched as a single completed unit, much like the other space stations at the time. The interior of Skylab was so enormous that there was actually a viable concern that astronauts could find themselves stuck in the middle of the station with nothing to grab onto. They would simply have to wait for minor air currents to push them towards a wall or request help from a crew member. However, they later found that they could just swim if they had to, pushing air with their hands to create a very minor amount of thrust, which allowed them to slowly move around. Getting stuff into space using rockets is, as you've likely heard many times before, incredibly inefficient. The amount of fuel and thrust you need depends on the mass of the spacecraft. But the more fuel you take with you, the more massive the spacecraft becomes, and thus you need even more fuel. But then the spacecraft gets heavier, so you need more fuel, thus adding more mass to the spacecraft and thus requiring even more fuel. In other words, there's a limit to what rockets and chemistry can provide. It's pretty insane when you first realize that when this space shuttle reaches a stable orbit, it's lost more than 85% of its mass, because 85% of its total mass was fuel. More fuel is needed to get from the surface to orbit than to get from orbit to the surface of the moon. It's been estimated that if the Earth was 50% larger, we would not be able to venture into space at all. Not using rockets anyway. I mean, the reason NASA and the Soviet Union began using rockets was to get to space first. It wasn't about long-term efficiency or sustainability. It was all about winning this global contest of firsts. And rockets were great for that purpose, but once we started thinking of going to Mars, establishing colonies on other bodies, building giant space stations and the like, we ran into some problems. The ISS, for example, is possibly the most expensive single thing ever constructed at an estimated cost of $150 billion. Many other methods have been proposed, of course. A space elevator, space plane, nuclear pulse propulsion, mass drivers, launch loops, beam-powered technology, skyhooks, a space tower, space gun, balloons, and the list goes on and on. Each and every one has its own unique set of advantages, disadvantages, and problems we may have yet to solve. But it's kind of funny when you think about it, because we've done some amazing things. We've walked on the moon, we've visited and landed on multiple planets, moons, and other celestial objects. We've built a space station as large as a football field, and we can detect other planets orbiting other stars that have the potential to sustain alien life. Yet this insignificant expanse of about 100 kilometers or so remains as one of the biggest obstacles to space exploration. The Curiosity rover on Mars landed on the Red Planet on August 5, 2012. One of its many objectives is to dig up and analyze the Martian soil. To do this, an onboard instrument abbreviated as SAM will resonate at different frequencies so that the soil can pass through various filters for analyzation. And it sounds like this. Now, to celebrate the rover's one-year anniversary on the planet, scientists at NASA thought it would be fun to use the very same instrument to play the Happy Birthday song, which gotta be the saddest and most depressive celebration in history. Given a certain pronunciation of a certain planet named Uranus, Uranus has been the butt of a joke ever since it was first named. Even I can't resist at times. Oh, and 63 Earths can fit inside Uranus. Both pronunciations are correct, by the way, but astronomers and most of the scientific community seems to prefer Uranus over Uranus. My personal preference is your mom, but it could have been much worse. Consensus on the name for the planet was not reached until almost 70 years after it had been discovered, because the guy who discovered the planet wanted to name it Georgium Sidus, which means the Star of George, in honor of King George III. In other words, Uranus could have been named George. Besides humans, many other animals has ventured into space. Many of you have likely heard of the dog Laika. She became the first dog to orbit the Earth back in 1957. However, the very first animal in space were fruit flies aboard a rocket launched in 1947. In 1949, the first monkey was sent into space, and in 1950, the first mouse was sent into space. By the late 1960s, many other animals like hamsters, turtles, rabbits, cats, frogs, goldfish, various insects, etc. had been launched into space as well. The result of these experiments has been crucial to our understanding of both the short-term and long-term effects of living in space, not just for humans, but for the animals themselves. For example, in 2008, researchers found that cockroaches that had been conceived in space became faster and stronger than their Earth-dwelling siblings. Many birds will never be able to survive in low-gravity environments, as they actually need gravity to swallow food. Humans don't, but when the US and the Soviet Union first sent people into space, they had no idea if weightlessness could somehow impair our ability to swallow. If that had been the case, the first human in space could possibly have died from asphyxiation or starvation.
It's one small step.
This quote by Neil Armstrong as he takes his first steps on the surface of the moon is possibly the most misquoted quote in recent history. According to Armstrong himself, he didn't say one small step for man, but actually said one small step for a man. Something the world, newspapers and listeners at home back in 1969 completely missed. And if you think about it, it doesn't make much sense. He would basically be saying that's one small step for mankind, one giant leap for mankind. But there's no audible A in the recording.
It's one small step for man. It's one small step for man.
Then again, there's a lot of noise which makes it difficult to hear exactly what is being said. Maybe he thought he said for a man but accidentally fumbled his words, or maybe it's simply obscured by the noise. Given the fact that all the gas giants in our solar system has rings, one would assume that planetary rings are quite common in the universe. So far we've found over 2,000 exoplanets, but as far as we can tell, none of them have rings. Except one. And it's truly an exceptional exception. It's called J1407b and was discovered in 2012. The rings around this planet have an estimated radius of 90 million kilometers. Saturn's rings are tiny in comparison with a radius of less than 500,000 kilometers. If we replaced Saturn with J1407b, its rings would be more prominent and brighter than the moon in the night sky. It's common knowledge at this point that the main driving force behind early space exploration was the fierce competition between the two Cold War rivals, the Soviet Union and the United States. In the midst of this looming fear of global nuclear war, and with the world as their audience, these two superpowers wanted nothing more than to win. In 1962, US President John F. Kennedy addressed the nation in a now famous speech.
We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
The Soviet Union had already beaten the US in many significant milestones. The first satellite in space, the first photo of the far side of the moon, the first human in space, and the first flyby of another planet. Putting a man on the moon would surely gain the US a clear lead in this escalating space race. And as we all know, in 1969, Kennedy's promise came true. But on September the 20th, 1963, Kennedy made a very different speech.
I include among these possibilities a joint expedition to the moon. Why, therefore, should man's first flight to the moon be a matter of national competition? Why should the United States and the Soviet Union, in preparing for such expeditions, become involved in immense duplications of research, construction, and expenditure? Surely we should explore whether the scientists and astronauts of our two countries.
He proposes that the US and the Soviet Union should join forces in their efforts to reach the moon. Initially, the Soviet Premier Nikita S. Khrushchev rejected Kennedy's proposal. After all, this was at the height of the Cold War. Unsurprisingly, any form of collaboration between these sworn enemies would be met with strong opposition. Many decades later, it was revealed by Khrushchev's oldest son that his father had had second thoughts. Khrushchev had supposedly changed his mind and was in early November of 1963 ready to accept Kennedy's offer to convert the Apollo lunar program into a joint project between the two superpowers. He believed, just like Kennedy, that both countries could benefit from a collaboration rather than a competition. The Soviet Union had far better rocket technology than the US, and the US had more advanced computers than the Soviet Union, not to speak of the economical benefits of a joint mission to the moon. On November the 22nd, 1963, President John F. Kennedy is assassinated. Because Khrushchev doesn't trust the new president, Lyndon B. Johnson, all plans for a joint mission to the moon dies along with JFK. The story is fascinating because it had the potential to change history forever, not just in terms of space exploration, but it would surely have improved US-Soviet relations. Just imagine how different the world could have been if astronauts and cosmonauts had stood on the moon together.